I see that my left-hand loop has a current source. And when I just have a current source, sometimes it can be hard to figure out what the voltage change is across that current source. And so KVL on the left-hand loop is not that useful to start off with because I don't really know what the voltage change is. So if I'm going to do KVL, I should do it on the right-hand loop, because that one doesn't have the current source, because current sources are difficult with KVL. Now KCL, on the other hand, will be really useful on this one because at this node, I already have the currents that I'm looking at. They're already all drawn in for me, and I even know what one of them is. It tells me IA is 2 milliamps. So at this top node, I can say that IG, so this is KCL, IG equals IA plus I0. And I know that IA is 0.002. So I have that equation. I can also I can say that I have ground here if I wanted to. And I can say a KVL going around this loop. Notice that I have the same current through all three of these resistors. Now those three resistors are in series, and so I could replace them with an equivalent resistor of 8 kiloohms. I'm not going to do that here because I don't. Have y'all done resistor simplification in class yet?
Yeah.
You have. Okay, so I will do that because that'll make this a little bit easier. So these three are in series, and I'm not. I will go back and do this yet another way after we do this one. So this is 8 kiloohms and 2 kiloohms. So that will make this one easier. I'd get the same result if I didn't do that. But now going around this loop, I have I0 here. So the voltage change, and I have IA here. So the voltage change through the 8 kiloohm resistor is IA times 8 kiloohms. Now notice as I'm going in the loop the way I have it drawn, up that central branch, I'm going in the opposite direction of IO as it's drawn. So that will make that minus IO times 2 kiloohms equals 0. So I now have that I have 8,000 IA minus 2,000 I0 equals 0. And, or is that IA or was that IG? That was IA, yes. Did I do the wrong thing here? No, I didn't. I know what IA is.
Why is I0 negative again?
Why is it negative? It's only negative in my KVL expression, and the reason it's negative in my KVL expression is because as I'm using the I0 as drawn, and I'm doing that because I already took into account that I0 is going down this loop when I wrote my KCL equation. The direction was important. And now in my KVL, as I'm going around my KVL, when I'm going in the direction of this loop, then when I'm going in the direction that my loop is going, I'm going in the opposite direction that IO is drawn. And since I'm going in the opposite direction of IO, then what I'm saying is in my KVL, I'm saying what is my voltage change going from this bottom part to the top part? What is my voltage change going in that direction? And my voltage change going in that direction would be the current going in that direction times the resistance. Well, I don't have labeled the current going in that direction. I have labeled the current going in the other direction. The current going in that direction is negative I.O. And that's why I made it negative here.
Okay, thank you.
You're welcome. Okay, so I think this is going to be not so bad because I know what IA is. IA is 0.002. And that has to equal 2000 I0. And 8,000 times 0.002 is that 1.6 or is that 16? There's too many zeros. It's 16. 16 equals 2000 I0. So 16 divided by 2000 is 0.008. So I0 is 0.008, which is 8 milliamps. So we found I0, that's 8 milliamps. Now it's easy to find IG because I have my other equation right here. IG equals 8 milliamps plus 2 milliamps, or IG is 10 milliamps. So those weren't so bad. Now I need to know the power delivered by the independent current source. Well, the power equals IV. So power equals IV. And I know the current, and I know the current going in this direction for IG. I know what that is. It is 10 milliamps. What I need is the voltage change across this current source in order to find what the power is. So a current source doesn't have a resistance, so I can't use Ohm's law. What I can do is say that my current source is in parallel with this resistor that's in the middle branch. And so whatever voltage I have on top with this 2 kilo ohm resistor, that has to be the same voltage that I have on top with the current source, because these two are in parallel. So I want to see what the voltage change is across this 2 kilo ohm resistor. So delta V across the 2 kilo ohm resistor will be the current, which we said I0 was 8 milliamps, or 0.008, times 2 kilo ohms, which is 2,000 ohms, and 0.008 times 2,000, would that be the same as 8,000 times 0.002? I think so, so that'd be 16. But I want to be careful that I know which side is bigger than the other, because I just said that the change is 16. So I have that my current is going from top to bottom, and it's a positive current, so that means that my voltage on top is greater than my voltage on bottom. So I've got 16 volts here and 0 here. And that means that over on this branch I have 16 volts there and 0 there, which means that if my current is going in this direction, then it's entering into the negative side of the voltage of the current source, because this side is smaller than the other one in the direction that my current is going. And so my power, when I'm looking at this current source, is going to be the current, which was IG 0.01, times my voltage, which is negative 16. And so that's negative 0.16 watts, or 0.16 watts supplied. And it should be supplied because current sources supply power. Voltage sources can use power, or they can supply power. So they can use power because, like, they're absorbing, they're charging. But current sources should be supplying power. I don't want to say that 100% because current sources aren't really real. They're approximations for other things. Okay, so questions on this before we go on and look at another one?